of AI. So we have been doing this since March. Every single month we have one or two classes. We started with natural language processing, then we went to computer vision, then we had fundamentals of AI, which was a very in-depth class. It was very interesting. Then we had a break, and now we restructured to put together this data science curriculum. Our goal is to grab someone who doesn't have the knowledge or has some idea, and in the end of 4 months, this person will be able to find a position as a junior data scientist. How we are doing this? We have this class, Machine Learning 101, and Python. Python is taught on Thursdays, and it's not us, it's Bloomberg. Bloomberg is teaching this. And we have an advanced class, a natural language processing class that is going to be held tomorrow. Kashyap is going to teach. Kashyap is my co-team. Okay, so basically the track goes, you go to Python, you go to the Python course. I'm going to assume here that you already know a little bit of Python. And then you come to Machine Learning 101, then Machine Learning 102, and then natural language processing and deployments of solutions in the cloud. Now, we're going to have next month, so this month we have Python, for those who are beginners and already know some Python. Is this correct? Okay, so again, we have Python. That's for the entire beginners. We have Machine Learning 101 for those who knows a little bit of Python, who went through this course and wants to start doing some machine learning. And NLP for advanced. Next month, we are going to have, so in October, we're going to have Machine Learning 102. So it's going to be a little bit more advanced than what we're seeing now. And deployment on the cloud. The other month, we're going to repeat. So those who are beginning now, so those who are on Python classes on Thursdays, they're going to do Machine Learning 101 in November. And in December, they're going to do NLP, and they're going to be ready to find a position. Basically, that's the structure. Is that clear? Okay, so we have a lot of people here, a lot of new faces, which is great. This class, Machine Learning 101, this is going to be a basic, the first class is going to be very basic. Sorry. And we are going, in the end of this month, we are going to be building recommendation systems. So the first class is going to be naive in some sense, and that's on the description. The second class, we're going to start to build some models. The third class, we're going to more advanced models, and the fourth class, we're going to build a recommendation system. The good news is that I hope that in the end of this class, we are going to be able to put out there our first recommendation system, a simple one. It goes this way. Now, what is the approach here? Guys, that's machine learning is a huge field. It's an intersection between mathematics, optimization, computer science, and statistics. So it would be very, how do I say this? It would be very hard to try to tackle every single thing in 1 month, and actually classes of 1 hour and a half. So the approach that we take, and usually that we have been taking and has been successful, is we do a hands-on approach. We get the data, we go directly to the data and try to find some insights. And we have some background, theoretical background, but it's hands-on. And now we are going to experiment with to have a hands-on, more hands-on session in class. Questions?
When you get to the notebook, if you're locked out of the class, you have a form now, and it's like hit the button, and it's like, sorry, email so and so or whatever. Is this someplace else?
This notebook is not.
It's locking me out.
Did anyone have success getting the notebook or not? Yes. So check it again. Refresh the page because maybe I put it on another notebook before. Done.
So it's a form.
It says, if you would like, please email Torture or yourself.
So maybe there's a registration page or something.
That's because well, you have to be logged in on the bad news. The mouse is not working here. Of course. No. Because I got a different. Look, anyone with the link can add it. Copy link. Now let me go to my.
Can you post it in your GitHub? Just post the collab link and just cut and paste it.
That's the same link. Try again. Because maybe there are a lot of people trying to input this. Okay, let me see what else. What else do I have to say? What else do I have to ask? The YouTube link is for those. So you see, there are a lot of people here, and that's why we started to broadcast this live, because we are a little bit over the maximum capacity, and usually people feel uncomfortable. We don't have enough seats to everyone, and people have to come to sit. We have cases people sitting on the floor, in the window. There's a space over there, but and you can watch the same class at home with a popcorn. Much better. Yes.
Question on you mentioned the other session, NLP. I believe that's tomorrow.
Tomorrow.
So you advise that we can take them parallelly like this today and.
No, I would advise to, if you don't know machine learning, take machine learning 101. If you do know machine learning, you're going to feel very bored here, I think. Because the goal here is to grab the most basic questions and answer them. So we can grab this person until the point where they're going to take the NLP. Later we're going to have other classes, advanced classes as well. But that's the goal, is to grab someone that doesn't have the knowledge and bring here. So I probably, if you know already statistics, if you already have experience with that, this is going to be very good. Okay, questions? So, so everybody clicked on the link, right? Now, what you should do is, you click here, File, save a copy in Drive. This will create a copy for you that you can edit, and we're going to use this. We're going to use this in class. So I recommend that everyone does have its own copy so we can work out, because later we're going to have some exercises, in class exercises. Okay? So click here, save a copy in Drive, creating a copy, and voila, you're going to have your own version that you can edit, you can delete stuff, you can add stuff, and it's yours. It's not. Please do not edit the first one, otherwise we're going to be cracking. Do not run this one. Run your copy. Okay. All right. Thank you very much for being here. Who here has the knowledge, has machine learning knowledge? So, what is your goal with this class? So I can adjust this the best way. Here, everyone here, who here is trying to change jobs? Okay, fantastic. The good news is that there's a seat over there. We have had people who took the classes here and found jobs. So that's the good news. Who here is interested? Out of those who didn't raise their hands first, who are only interested in understanding what is AI, what is this fuss? What are people saying about it? Is here?
In terms of
well,
operation.
yes. Okay, so let's get some jobs. Let's start. Guys. Is everybody on the same page on Colab?
No, because you can't get to the link.
Again?
No, we could. Go to the meetup link. Somebody posted it. We were able to get it. Look at the comments below. The first one.
Here.
Yeah.
Meetup.com.
Did you see the comments yesterday?
Sign up.
Well, I don't know if it's how mobile friendly.
You have to log in on Google, on meetup.com.
Just file and save. Yeah. Save and save.
Let me put my account here. Just a second.
I think so. Yeah, but this is the actual program on YouTube that is streaming it. That's okay.
I haven't even opened all of them.
Okay, so there's a seat over here. Too late.
Keyboard.
Oh, there are places on the wheel.
Actually, so.
Sorry for that. There's a YouTube live being broadcasted. All right, so machine learning 101, and this first class is descriptive analytics. What is this? What's the idea? Basically, you're going to have a question, you're going to have a problem, you're going to receive a problem that you want to draw some insights. In our case here, I grabbed a database on Black Friday. So it is a Black Friday sales in some country, some place. The database is from Kaggle. Now, I'm going to show you a very interesting thing. If you go to kaggle.com, that's very important for data scientists to know this website. Here, you're going to have a lot of challenges. You're going to have competitions. And you actually can make some money. $120,000 for still defect detection. Blindness detection. You have some challenges that companies post there, and you're going to try to figure out the best prediction model. So this is very interesting. This is a very good resource for beginners. They have beginners classes, not classes, but challenges that already have the solution. So if you're thinking about migrating, someone asked me about resources to start on data science. This is a major resource. This is very important. Okay, now there's another thing here that is very interesting. Whenever you're trying to find some databases. So you can build some proof of concept. They also have databases here. So you can type, oh, you're seeing my retail, for example. That was our case. So I'm here searching for a retail. We have notebooks, we have data sets, we have topics, we have competitions. So we have a lot of resources that we can find here. In our case, if you want to find a database, give me another category. Not retail. We're going to use retail. Another one.
Finance.
Finance. Let's see what they have in finance. Probably the competitions on finance are going to pay more. Let's see. Oh, they're all closed already. Okay, but you see the companies, just like Santander, for example, to Sigma. You see the prices here, 60,000, 100,000, 50,000. So those are the prices for the competitions. Later, if there's a demand here for us to build a group to start tackling these competitions. Maybe this is something that we're going to do later. Okay, finance. And let's see, databases, datasets. So 544 datasets. I can filter out small, medium, large. Let's see the large datasets they have. This doesn't look fine. Oh, Bitcoin blockchain. Okay, so basically this is summary. This is a very good resource. You should check this out. This is actually this is where I started. There's the Titanic challenge. The Titanic challenge, it's a little bit creepy, but there are some variables that you can predict if the person, the probability of a person to survive or not. So let's say if gender, of course you can imagine that males have more chance to survive than females, correct? No. Thank you. No. So yes. So that's you have this data set. You have the data set where they embarked. There were 3 ports in Europe. So there are a lot of, and you have a lot of notebooks of people who done this challenges before. In our case, we do have. I posted this. Like this. So that's the original data. Okay, so that's the database. That's where I got the database for Black Friday. Now, there are 3 kernels, actually 1 kernel, a kernel. If you click here, you're going to see that you're going to have 3 people who already worked with this database inside the environment. So kernels are environments inside the Kaggle environment. But actually only one is relatively good. And okay, so someone edited already, but let's start running this. Okay, so I'm assuming that you already know some Python. And those 4 libraries, and mainly Pandas, NumPy, and Matplotlib, they are very famous. Everyone knows this. They are libraries that allows you to work with data. They're going to put the data into a very good structure so you can work with. I'm going to use a lot of Pandas. NumPy. So Pandas is a data frame. I don't know if everyone took machine learning Python. So Pandas is a data frame that accepts different type of variables. So you can have text, you can have integers, floats, different types. NumPy NumPy is only used for numerical variables. So when we move to deep learning, we are going to use NumPy a lot more. But that's in the end of Machine Learning 102 and all the other classes. Right, so let me run this. So if you grab the data from here, you're going to download the information, and you're going to have a few files. Those files, to make it easier for us, I uploaded to our GitHub one of these files, the train.csv. And it's just one of the files that you're going to download. Now this is the largest one, so and usually that's where you start to work. Now we do have here so Black Friday we have user ID, the product ID, gender, age, occupation, city category, stay in current city years, narrative status, product category 1, 2, and 3, and purchase. This, I'm assuming that this is a value. I don't know which currency, so, but think of this as a value. Okay? So, let's, so far it's a little bit boring. Let's think differently. It's 1 month before Black Friday. We work at eBay. Our boss comes to us and says, look, what are we going to sell? What are we going to focus our advertising? So which kind of products do we have to target and to whom? Now, what do we have to do? The idea here would be to segment, to stratify the potential clients, to understand the different groups. What is their behavior? What is their purchase behavior? And then our boss says, look, we do have this previous data set. That's what happened last Black Friday. Run some analysis and please give me some feedback. I would like to understand how we can set an advertisement strategy. That's our challenge. That's what we're trying to solve here. Okay? Now, what is the first thing that you do whenever you have a challenge like this? You grab the database, you grab the code, and start coding. Yes? No. I have to think about the problem because we are immersed in it's a world of databases. It's a world of not information, it's a world of data. And there's a clear difference between data and information. That's the most important thing that you have to remember. By the way, usually in those classes, we do AI for business. We want to build something that we're going to implement. So I'm going to bring a lot of business insights, and I welcome you to bring your insights as well. Because I know that basically AI is nothing without the domain knowledge. The domain knowledge is the most important thing. AI is going to help the person with the domain knowledge to actually to potentialize your work. So the domain knowledge is very important. Now, my first startup was called Emoji. It was an app where people in Brazil, and Brazilian by the way, people in Brazil could complain about public services, could indicate what they are thinking that, what are the issues. So you had 4 squares: health, security, transport, and education. And people could complain about those things. A friend of mine said, look, Vinicius, it doesn't make sense to people report even more because you have already this data out there. You're going to spend a lot of money building an app to collect information that is already out there. And then I said, no, but we need the information. People need some place to complain. And everybody that I was talking to, and they were saying, oh, this is fantastic, I need this too. And then I paid a lot of money for developers to develop the app. In the end, I lost a lot of money, and I had, I don't know, 400 users. It was a drag. And actually, the data is out there. The data already is out there. You can find this information on the web, on the comments. If you do scraping, if you go to Twitter, NLP is going to do Twitter analysis. And the NLP class is going to go to Twitter based on some keywords. They're going to retrieve tweets and run some analysis. The information is out there already. So we are immersed in a lot of information. Now, what we don't have are two things. One, good questions. And two, find places. Where to find the data? Where can you find the data? So this Kaggle resource that I've shown you, this is one place that you can find data. There are a lot of other ones. So yes, now we grab this data and we have no idea about, well, basically we have nothing. I'm going to ask you one question. Which product would you recommend for a person that is in his or her mid-50s? We don't know yet. So that's where the descriptive analysis, that's where it enters. We are going to draw the first insights about this. The first information, not data. Information is data with intelligence behind. Now that's the goal. So, which would be the questions that, so you have, let's pretend that you only have age. Which would be the questions that you would raise? Black Friday. Black Friday is going to help.
Which age spends the most? Or like
Which age spends the most? That's fantastic. So spends the most, there are two things. Spends the most. Two questions behind this. One is the age that purchases the most, and the age that in average, the average purchase is the highest. Because then the combination brings these insights. And so beforehand, what would you think? Which age do you think buys the most? Your 20s.
older, 30 to 40.
40s.
30 to 40? In between
30 to 40. I would go with 30 to 40. Of course, I've seen the data. But I might be wrong. And which age spends the most in average? The most expensive things?
50 plus.
50 plus. Let's see. Okay. Oh, yes. So this is very important. This guy here is checking if there are NAs, no information in the columns. So it grabs for every single column in my pandas data frame. I'm going to check if the column has NAs. Basically, this is going to give me true or false in a column. When I sum up, it understands that I'm summing up true or false. It's going to become 1 or 0, and 0 means that there are no NAs. So only on product characteristic 2 and 3, we're going to have NAs. Product characteristic 1, we don't. And the rest we don't. So it's a pretty good database, yes.
So is there a way to know which variable these are for? Because sometimes if you have a large data set for 100 variables,
Yeah, definitely. That's just because I put it this way. But there are other ways. This we should do this.
Excuse me.
Thanks. Will you keep it quiet, please?
is not going to bring. Definitely there's a command here, but what I would do is for x in data.columns. Some data text dot is in main. All right. So 0 for user ID, 0 for product ID, and we have a number for these guys here. Probably there's we like to say a Pythonic way to do that, but this works. The Pythonic way probably does this behind the scenes. Okay, so the good news is that we have good the database is very good for us. There are no NA, so we don't have to worry about this. In later stages, I'm going to bring more messy data to show you how to work with these NAs, how to work with unbalanced data, things like that. That's very important. This function here, I just put it to generate different colors to make it a little bit prettier. But remember, I'm not a designer, so it's not going to be super pretty. It's going to be randomly pretty. Data info. So those are the columns that we have. All right. So here are the number of transactions that we have. 550,000 transactions in 16. The number of unique buyers, almost 6,000, and the number of unique products, 3,631. Now, distribution by age. I run this. Right. So that's the distribution by age. I grabbed what I did here, and I would like to ask you if this is the correct way to do that. I grabbed every single purchase, 500,000 with 550,000 purchases, and I grabbed the age of the person that purchased that item. And I did this distribution. So we have 40% is between 26 and 35. And so on. So we do have a very good global distribution here. But this, so that's I brought this chart to show an interesting thing. Data description is not it's a little bit tricky because the information that you're grabbing might not be correct. So what I did here was to grab every single purchase from the 550,000 that we have. Check the age of the person and say, look, there's a person that is 22, another person that is 15, another person that, and I did this distribution, and now I believe that this distribution is the distribution of the population that I have. Why is this wrong?
It's not showing you the amount what they bought.
I'm sorry?
It's just the number of transactions went through, right? You're not calculating the amount they spent on each of the items.
No, we haven't reached there yet. We're going to use that information. The problem here in this case is that what we are looking is to the age of people who the age of each one of the purchases. But actually, our data set, the same person might have purchased a lot of items. So we are actually double counting, multiple counting the same person. Well, those are there. I saw that chart in one of the kernels that on Kaggle. And then the person said, look, that's the distribution of age of our database. I said, no, it's not. Yes?
The age groups are not the same either. Like you have 51 to 55 and 18 to 25, and you know
They're not distributed equally yet.
Yes, they are not. They are not. That's yes. So the bins you can select the bins the way that you prefer. 5 years. That's usually this guy has some. I forgot what is the automatic way to select the bins, but that's a very good point. That's a very good point. This should be done corrected. We're going to do that in the exercise. Thank you very much. So that's actually the distribution of the age, not this one. So we still have the majority between those 25 to 34, I think. But it's not that large, and the 50 plus, 55 plus is a little bit higher than what it looks like. So this for recommendation systems. Now, there's a difference when you have a recommendation system that can gives you an accuracy of 40%. To reach 80% is very easy. To reach 90%, it's super difficult. Now, to reach 95%, those small differences matters a lot. So that's why you have to be very careful regarding every single analysis that you do. Right. Now, by the way, the good thing about this Google Colab is that you now have this, and you can run analysis on any data set. You have the code already, and you're going just to change the names, the name of the variables, and you can get the information. So we ran this, right? Okay. Now we're going to enter the purchase part. So here we have average number of purchases by age, group, and average. Oh, sorry. Let me go back here. I got lost in the code. Now we do have this sample. We have this database. That's the distribution of age, and what we want is to draw insights. Draw insights of the number of people who entered the website last year. So what does this give you? Pretty immediate. You have a clear pattern of who are the majority of the people who entered your website. So whenever you're tracing this strategy, this is something that the amount, because remember, this, you're going to put money on this. So the return over the investment that you made must be high. So this is the majority of the investment that you're going to make on marketing. So every single graph that we have here, we have to think of terms of investment. Where are we going to grab the value? Now let's go to the average purchase. So we have two things here, the average number of purchases and the average value for each one of the, how do I call this, the average, what's the?
Purse.
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 Now, average number of purchases, in average. So this is going to be the 20 to 30 and 30 to 40. So I think that you said that this is going to be between this. Yes, so you were correct. Now we have 18 to 25, also high, and we have a very nicely shaped. The surprising story is here. Because my money was on that this would be like this. We would have elderly people buying more expensive stuff. But actually, no, not on Black Friday. This graph shows that this doesn't happen. So my first strategy, before looking at the data, I would say, I'm going to put I'm going to recommend the expensive items to elderly people, the cheap items to young people. I'm going to do that. But what this graph shows is that this is not the best strategy to approach. And actually, value is something that you shouldn't care much. Maybe later we're going to see that a category is going to be important. So electronics, I don't know, cell phones on Black Friday probably sells a lot, and a lot for young people. They wait for the Black Friday, and cell phones, they are expensive. They are an expensive item. That's why this is high. So that's this is the first information that was against the common sense. And actually, this is going to be surprising for the manager when we show this. He's going to look and say, okay, I didn't know that. That's nice. So, you see the, I don't know, 3 graphs, and we already added value to the campaign without using any machine learning, just basic stuff, very basic stuff. Okay, now you do have the code. I'm going to go through the code. 7:16, we have 44 minutes. Okay, we're good. So you do have the code here. I'm assuming that you already know Python. I would like to please copy this, copy everything, run the same analysis for gender and city category. Let me try to zoom out. So that's the code, and I would like you to run the same analysis for gender and city category. So first city category, and then for gender. Please do this. I'm going to do as well because I haven't seen the results. For those who are a little bit lost on how to do that, follow me now. Those who already know, feel free. So you copy it and you paste it here, okay? Now we did this analysis for age. We had age here. Now what we want is to change this for gender. Everything that has age to change to gender. And remember that the G, caps lock G, and the rest lowercase.
Change the variable name?
Sorry?
So we change the variable name, sir. The variables you like underscore.
No, the variables you're not changing.
There's another thing that I have to change.
I mean, would you have? On the left hand side.
On the left, yes, the name, yeah, no.
I mean,
That's true, that's true. So that's, yes, we lost the information out there, but
I remove it.
okay, so the result that we have when we run this for gender is the average, surprising, right? You say, come on. I don't think that's surprising. But this is also something that would come to the attention because males actually has a higher average purchase and average purse, and also they buy more. Now, regarding buy more, we can discuss regarding the bias of the database. We are assuming that this database is the entire population that entered the website on Black Friday. But it might, that's a whole different discussion that we're going to have in the end. But yeah, so again, new insights that we didn't know beforehand. Right? Now let's do the same thing for city category. Let me copy this. bases together. There's an underscore here, city underscore category.
Alpha data.
Ah, 11. Yeah, no, the mistake is if you go, here. So, the city category is not working because beforehand, when I used, remember that I did this code to get unique users. Remember that we had a lot of users, actually duplicated users. So what I did here was to drop duplicates on this. And as the same user has the same age and the same gender, and I'm dropping every single duplicate. And probably the same user is in the same city. But that's not very good to assume beforehand. So I'm not going to cancel the city category challenge here, because it's not safe to assume that the same user lives in the same city. He might have moved. Although this is very low, but it's nice to be careful. It doesn't add much to our analysis here. Okay? Jim, ask your question.
$9,000?
I'm sorry?
$9,000? Are we talking about dollars?
No,
here?
no, no, we're not.
What's
I don't know the currency.
Okay.
I don't know the currency. It might be yens. It is 50 cents. The Tanzanian, oh, it might be pesos. Brazilian joke, right? Okay. Now moving forward, this didn't work. I'm going to fix this and I'm going to send you the code. Right. Now, let's run this one. Now, what we did here was, so far, we have been looking into only one variable at a time. Gender, age, etc. Now we are going to look into two variables. Why I did this? Because it's interesting, of course, and in the end, what we are doing we have a lot of we have different people, and we have characteristics of each person. Now, what we are doing here is to group those guys by characteristics and seeing their behavior. After we do that, we are going to see the average purchase and what kind of product they purchase. So that product we are going to recommend. I'm going to say this with an example. Imagine Netflix. We are doing Netflix here. So Netflix, whenever you enter there, there's a probability that you're going to like this movie, 98%. Now, in my case, I have, I don't know, probably there's going to be a comedy or something, some historical movie. Why? Because I watch novels. So in my categories here, instead of having a city that you live in, they have comedy. For me, there's going to be a lot of ones. So you watch this, you watch this, you watch this. Horror movies. I haven't watched one for ages. So that's entirely zero. So they classify, they segment the customers by characteristics. And that's what we are doing here. Now, we are adding a second characteristics. We were looking only to age beforehand, and now we're going to add gender. and see what are the insights that we're going to come up with this. Okay, so we have here the distribution. That's the number of purchases. Yes. So average purchase age and value purchased. So the number of purchases, and here is the value that they spent. We have here age, the age means, and we have gender. Now let's go to the graphs. So average number of purchases. Looking at this graph, what would you say? Here we have female, here we have male. The question is female/male an important characteristics to make any prediction regarding purchase patterns?
Yes.
Why?
Well, the shape is about the same, but one is higher.
Yeah, value.
Beautiful. So they kind of move, the shift is only upwards, but the shape is the same. This means that the difference in ages, it doesn't change. But in gender, yes, it does. We've seen before that males buy more items than females in this database. So that's what this is showing you. Maybe you might argue that you're going to have some small differences here, and this is the 90% to 95%. This is going to be taken into account in our third class to make the recommendation system. Okay, does that make sense? Now, average value of purchase. Do we have some differences here? Would you do a different analysis? There's a difference between them, but don't you think that's a little bit odd that here you have homogeneous purchase, and here you actually have a decrease and an increase here. So this means that, remember that we mentioned before when we looked only to average value purchase, that it was horizontal, we are not going to do any different strategy because they have the same purchase pattern, the same value expenditure pattern. Now, on females, we do have a difference that we don't see here much. So this, for the strategy, for the marketing strategy, is going to be important. You can add in your notebook saying, look, we already have, what do we have? The non-common insights, male spending more. What was the other insight? The horizontal expenditure. But now the horizontal expenditure changes and says, okay, for male this is true, but for female, no, we should have a different strategy regarding age for females. And what is the job of a recommendation system? Is to grab as many characteristics as you can and add dimensions here and find those small nuances. And then in the end, you're going to be able to target a given person. I would like to show you this. Just this is going to take a second. We have half an hour, so we are good. Now, let's see if I can impress you, because I see a few people sleeping a little bit, people a little bit boring, some snoring. Let me show you what we do in practice. Next, clients. This one. Analysis result. So, usually you segment your clients by age, gender, income, where they live. We have this information here. And nowadays you do have the browsing pattern, the cookies. It grabs everything, every website knows. If you enter, I don't know, into Ferrari.com, they are going to recommend a given price for a ticket. A different price than if you enter beforehand, you know, the Marshalls.com. So every single thing is captured, and I believe that the most advanced thing, the most advanced characteristics that is being captured nowadays is personality. So there are ways to capture personality. There is this theory called the Big Five. So that's a psychology theory. So we have, it's an anagram OSHA. Openness, consciousness, OCD, extravagancy, A for that. We do have here. I'm going to check, but N for neuroticism. What is A?
Neuroticism.
Consciousness, extroversion, agreeableness, yes. And of course, emotional range, but actually it's N, neuroticism. I don't know what it is. And every single personality has its information, its own subcategory. So you're going to have here anger, anxiety, depression, moderation, self-consciousness, vulnerability, and you have a number. Classifying every single person. This exists, and we use this to make this recommendation. So you can see here, I think that those are 52 categories, personality categories. So we did an analysis with 2 dimensions, gender and age. Now only, with this only, we can do 52. Plus gender, plus age, plus where the person lives, plus blah, 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 plus cookies, plus that's how Netflix recommends you the best movie that you're going to like, and usually Netflix is correct. That's pretty cool, no? Or scary. I like it. All right. So, 734. Okay. So now we do have another challenge. Please grab this and do the same thing for gender again. Oh, for city. For city.
Can I do it for city?
City is not going to work. Is it?
Didn't work, right?
I'm glad I have to change the code for city. I forgot about it. Later I'm going to post that. Oh, so just by the way, ideally, everyone here has enough Python knowledge to do that, to change this and make the whole code. So I'm not going to go through this. If you have issues, contact me and we can find a way to work it out. Okay?
Could you just explain this example? Why, in your code, why is it not working for CD?
Good question. No, it's not working for Siri because when we go here, I'm using this unique user's age. this database. So we have the whole database, and I filter out for unique users. So we could only look into the, we don't double count. Now, when I did that, way on the top, here, that's where I define unique users. So I define unique users as having 3 columns: user ID, age, and gender. So to make this work, I could simply do this. City, underscore category. Okay, now let me put here unique. Now we do have the city code. Now it's going to work. So go here. But I'm doing this in my code. Everyone has its own code in front of you. You can do the same and adjust it. Is this here? So now I'm going to change from gender or age. Which would you like me to replace? By city category. City category probably is big city, small city, and farm, I think. Okay, I'm going to change gender. Change gender. All right, it's very important. Oh, that's nice, right?
And this ABC, we have to go back to the.
No, that's what I don't know what is ABC. They don't disclose this when they give me the data set, but there are 3 different kind of cities. So that's why I'm speculating that one is a major city, the second one is B would be medium-sized city, and C would be farms. I would say suburbs, major city, because of the age. We have it, yes. Suburbs and here farm. Speculation. But you see that the city is a major predictor. The average number of purchases and the value that they spend, unfortunately, but you can see that, let's see. Definitely that's suburbs. Okay? All right. Now what is that? Let's see. Okay. So let me put here. And I did my master's in economics, specialized in econometrics. So it was a lot of statistics and very heavy stuff. And my advisor, he was one of the pioneers on statistics in Brazil, a known guy, a very respected guy. And he looked at me and said, Vinicius, all those techniques that you are learning, those are very important. But nothing beats well done descriptive analysis of the data. Sometimes, most of the times, most of the answers that you are looking for are not on fancy regressions. In our case, in fancy machine learning models, putting deep learning here to figure out, no. with this, we already get a lot of information that is going to be valuable for our marketing, or in this case, the marketing campaign. So this phase is very important for you to understand the business, to understand what are the important features. Let me drop this. I always keep losing the pens. I drop someplace, and then I have to figure out where to put it. That's very.
Yeah. So you mentioned education. So what kind of background would be be most important for this, and what kind of career path would be most important off of this? So for doing this machine learning, you mentioned economics.
I wouldn't look. I'm an economist. I did econometrics, and when I moved to US, I changed. Not changed, but I migrated. It was very natural to migrate to data science. But I didn't have a lot of training on computer science. Well, I spent, but the first year in Princeton, I spent a lot of time learning algorithms and databases. A lot. And actually, the market for data scientists, they are majority for computer scientists, engineers, computer scientists, for entry level, and later a little bit, because there's a difference. I'm sorry, what's your background?
Bachelor of Computer Science.
Computer science. So you're going to be good in this. People are going to like your resume. But remember, nothing beats domain knowledge. And as we move forward in age, the thing that is most important are the insights. And insights you get from experience. It's not something that is going to be taught. It's something that you have to go through. You've gone through a lot of different situations, and you start being able to connect A and B, and say, oh, yeah, there was a solution that I implemented here that I can implement here, or maybe this with this. Yes.
Sounds a lot like machine learning.
Yes, definitely. So that's career-wise. What I would recommend nowadays is GitHub. Build your portfolio. If you're looking for a job, if you're trying to change jobs, put an account on GitHub, start to do analysis, basic analysis like this. Then you move a little bit further. This class is this class was built for people to build their portfolio. Or when we design the class, we design thinking of this. You have to grab a problem, a data set. First, think about the question that you would like to answer. If you want to know, if you would like a job on sports analytics, for example, grab a database in sports analytics. Draw some insights from it. Probably someone already did that. Do as well. And put on GitHub, put out there. And on GitHub appears some squares that shows the frequency that you post on GitHub. It has to be everything green. A lot of stuff out there and a very good description of what you did. And you did this, blah, blah, blah. If you don't have a computer science background, this is going to be a little bit more challenging. Because the way that you structure the code, this way that I just did, that's not the correct way to put out there as in a software development. You have to start thinking about object-oriented programming. And you have to build classes, you build your classes, you build the algorithm design, and then you have a main file that is going to run. This is very good for reports. But that's what we're doing. Let me show you this. This is going to be important as well for everyone. What time? Okay, 15 minutes. There's a methodology called CRISP-DM, Cross-Industry Standardized Processes. Those guys, whenever you do some proposal, data science proposal, you have to put the methodology. Usually, you're going to use Agile and Scrum, and always for a data scientist, you should mention CRISP-DM. You should say, look, we are going to use CRISP-DM to develop this, to find these answers, to develop this solution. What is CRISP-DM? I'm going to put, Google it, you're going to have the beautiful version. But basically, you have a wheel, and you have something that comes out. And you have here the problem, you have the database that you're going to grab, you have the machine learning code. So you have the problem, you get the data, start to draw some insights, build the algorithm, and outputs. No. When you do this, when you reach here, the first analysis of the database, you're going to find that you need more data or you need more information to actually answer the question that you raised before. Or even more important, you're going to find that the question that you said, look, that's the question that we have to address, is not the real question. And then you go back. Change the question, collect new data, run new analysis. You're going to find out that you're not there yet. Although you found a lot of things, you understand that there are things missing. You do that again. Usually it takes 3 to 4 cycles, so you can come out with the final output. Why is this important? That's by the way, that's I work with consultants. I do consultants. If I don't say that to the clients, if I use the old kind of proposal, look, we're going to get your data, we're going to draw some insights, we're going to build a machine learning algorithm, and this is going to output some results. When you get into the machine learning part and you output the results, the client is going to say, no, that's not very good. It doesn't actually answer the question that we wanted, or it doesn't solve the problem. The question is wrong. But the time frame of the project is already in the end. And then you have 1 month to redo the whole thing. So the best thing, that's the best advice that I can give. Whenever as a data scientist you get some problem that you have to solve, grab the database, select the columns that are the easiest one to work, build the first algorithm, build the first insights, and do the first step. Because you're going to find a lot of things, a lot of information that you actually have to solve and you don't have in your first database. So this is CRISP-DM, C-R-I-S-P. Okay, what's the pen? It's not humble. This is very important. All right, we have 11 minutes. Let's rock. Okay, so far, we took the average value, the average amount of purchases, but there's a saying that the real information is not on the averages, it's on the variation. So this is very true in finance. In finance?
Finance is long tail, not averages.
Not averages.
Yes.
No,
And it's
not,
not
that's the
variation.
point.
It's also not standard deviation, which is averages.
It's the averages.
No.
No.
Finance is all long tail, which means it is outside of the standard deviation, which means
Yes.
it is outside of the averages.
Yes, no, that's the whole point. The dispersion is very high.
Yes.
So you cannot make predictions. It's very hard to make predictions. Whenever the dispersion is higher, you're going to have a harder time to make predictions. So basically, in other words, I'm showing this graphically. Let's say that here is age. We have product 1 and again age, product 2. Now, for product, what is the higher probability? Which product would you sell for a 50-year-old?
Age.
The second one.
What's the age on the second one? 30?
It's the same. Not very good. So 30, let's say that 50 is going to be.
Standard deviation.
So that's you have a higher probability of selling the second one than the first one. The first one is going to be very focused on a very in a niched group. That's why it matters. Although I try to draw this as the average, if you take the average value, it would be 30-ish. But in one case, you can say a lot of things, you can actually make a recommendation. In the second case, you cannot make a recommendation. You can, of course. But it's not going to be as precise as the first one. So that this code here, it looks for not only the average, but also the standard deviation of the purchase value. And what we find is that they also have the same standard deviation, so it doesn't matter. But of course, this should be done for other variables as well. All right, so 7 minutes. Let me just finish this. Here. So one thing that I like to give to you. You have this code. So you have the functions, you have how to do this. You have here the method, the Python script. So this, I like this script a lot because what we're doing here, you have your data, the first database, and you are filtering out people who are between 0 and 17, and those that lives in the city A. And I'm going to grab the purchase value of those guys. So this is a way to use pandas to filter out the category that you would like to assess. Okay, that's why I put it here. And whenever you make the assessment that you want, you say, I want to check the 55 plus. Do this filtering here. 55 plus here. And you filter out the database. Okay, let me. Where's the... Hey guys, I think that someone deleted my last code. The last code was the best one?
No.
Okay, so I'm going to give you this as a homework.
Well,
I've done this. You can do this with the code that is already here. I would like for you to output for each age the 3 product categories, or product category 1, that has the highest probability of that age by that product. In other words, we have, I think, 10 or 15 different categories that we get here. Data, product, category 1. All right, we have 20 different categories. Now, I would like the output to be the 3 categories that are most probable of being purchased by each one of the age means. So, between 0 and 17, what are the 3 categories that those guys buy the most? And what is the probability? How do I find the probability? Very simple. I count the number of purchases of each one of the categories, and I divide by the total purchase number. And you're going to see that there are a lot of differences between the ages. You're going to see that they actually have a lot of different patterns. And then, this would be the first recommendation system. Because you have the three products that you would recommend. I think that is correct. The category 8 for 55 and for 55 plus is the probability, I think it's like 25%, while 17, 10 to 17. 0 to 17 is 4%. So this product 8 would be recommended to 55 plus. So that's what I would like from. And of course, we are going to move forward to build better algorithms that are going to make these recommendations. So we are going to talk about clustering next class. We're going to cluster those guys. Okay? Questions? Yes, please.
So resilience was the underlying that we used to cover.
Yes. That's the main package that we're going to use to handle databases. Later we're going to use a lot of NumPy. NumPy, you're a mathematician, right? No? Well, but linear algebra. That's a NumPy is linear algebra.
Machine learning algorithms and libraries that we are trying to use.
sklearn, we're going to for clustering. Probably we're going to do a random forest, definitely. We're going to use k-means, k-nearest neighbors, but not with this database. Yes, I think we can do that. But I think that those are on the description of the classes. I think that the description of next class is linear regression and logistic regression, but I'm going to change from this is going to be on the 3rd class. And I don't even promise that.
Can we bring any use case and discuss?
I'm sorry?
Can you bring any use case and can we discuss through the session?
The use case?
Yeah. If you have any real-time use case, can you bring it up here and go through that?
Cases that I've developed?
No, he's gonna bring it.
Cases what we are developing right now.
Like when you have like
Okay? Yes.
So, may I do a shameless plug So, this Saturday, I'm going to do a workshop at Omar's class. He's at the Mercer County.
Oh, you want to say something to the class?
Yes.
Oh, come here.
Okay.
We have announcements. If someone leaves,
Okay, thank you.
should not come back. Okay, so we're going to have announcement time. Yes.
All right, thank you very much. So, that's my son doing the video. My name is Brian Greiner. We're buddies. So, there's a meetup this Saturday afternoon from 2 to 4 at Mercer County Library off of somewhere between 206 and like Morrisville area. And you can look it up. The meetup is called Princeton Cloud Solutions. Just look for Brian Greiner, business analytics in TensorFlow. So everything you're doing here, I'm going to talk through some things about how to use TensorFlow in this beautiful free environment Google provides to do stuff that you might have to do at work. And everything that Venetia's one over here, extremely important. Because if the data's wrong, doesn't matter what you graph. Yeah, there are plenty of people out there that can just point and say, that's wrong. Yeah. So, if you're interested, you can talk to me. I'm sitting back there. Try and find the link. But if you search
The meetup group, meetup.com.
yeah, I can send
and
it to you too.
Okay.
It's called Princeton Cloud Solutions. And yeah, 2 to 4 comes free. We'll just keep going. I have a workbook, like a time series thing I added multivariate. I haven't had a chance to show it to you yet. We're going to look at, Google has a metric out there on trends called interestingness. Something like awareness, whatever. But it's monthly. And so you can see what happens on the spikes. You can kind of work back. Anyway, it's a little goofy, but you'll see.
Thank you.
Thanks.
All right, guys, thank you very much. See you next Tuesday.
Thank you.